These are the rules for definite integrals, and we want to use these rules to solve some problems. So here's the first couple of problems we're going to work on. What I'm given is this information right here. So I am given that the definite integral from 1 to 2 of f of x dx is equal to negative 4. I am given that the definite integral from 1 to 5 of f of x dx is equal to 6. And I'm given that the definite integral from 1 to 5 of a different function, g of x, is equal to 8. And using that information, I'm going to try and solve a series of problems. Well, let's start with problem A right here. So it wants to know the definite integral from 2 to 2 of g of x dx. Now, this is the one that I like the best because it just makes such total sense. I mean, I could go back to the rules and look and see which one makes is similar. And it's clearly this one here, the 0, because if I'm trying to find the area under the curve from one point to the same point, well, I mean, that's going to look kind of like this. Here's the curve, and here's point A, and here's point A. Well, there is no area under the curve. So always when I have the same lower bound of integration and upper bound of integration, the answer is going to be 0. So the answer to A is 0. Now this one here is saying they want the integral from 5 to 1 of gx dx. Well, I know if I'm thinking about a number line, here's 0, 1, 2, 3, 4, 5. If I'm going from 5 to 1, it means I'm going from right to left. And integrals, when they are positive, are going from left to right. Well, when they're positive and above the x-axis, they're going from left to right. And I know that if I'm looking at the rules here, it says, well, this one here, I really don't like the way it is written. Because I prefer to look at it as if I have the integral from A to B, which I think of more as lower bound to upper bound, of f of x dx, that is going to be equal to the integral from B to A going the opposite way, from B to A, of f of x dx, but it's going to be negative. So on this particular problem that we're dealing with right here, I'm going from 5 to 1. Well, that is the opposite of 1 to 5, so the answer here is going to be negative 6. We're using the same information right up here. Now we're going to solve two additional problems. So I want the integral from 1 to 2 of 3 f of x dx. Well, I'm going to use the rule that says I can pull the constant through the integral. That's what I'm going to do. So I'm going to say this is the exact same thing as 3 times the integral from 1 to 2 of f of x dx. And I see that the integral from 1 to 2 of f of x dx is equal to negative 4. So this is the same thing as 3 times negative 4, which would equal negative 12. This next one, B, gets a little bit trickier. So it's asking for the integral from 2 to 5 of f of x dx. So I know I'm not going to be using this over here because that has a gx in it. But over here I have it from 1 to 2, and over here I have it from 1 to 5. So there's a couple of ways I can look at it. One is to kind of think of it, again, on like a number line. So here is 1, let's call it 0, 1, 2, 3, 4, 5. All right, that's as far as we're going here. And I know that the integral from 1 to 5 is equal to 6. And I know that the integral from 1 to 2 is equal to -4. So kind of logically thinking, I'm thinking that if I'm going to have a total of 6 from 1 to 5, here, oh, I made it from 0. I should have done it from 1 to 5. I'm sorry. Let's make this a 1. If I'm going to have a total of 6 from 1 to 5, that means, and I know that I've kind of lost 4 from 1 to 2. It kind of tells me that if I want to have end up with 6, the whole thing being 6 means that this piece of it right here has to be 10. I would be -4 here, +6 for the whole thing. The whole thing has to be, I'm sorry, from 2 to 5 has to be 10. That's kind of a way to think about it graphically, not the best way graphically, but really using the properties of integral is probably a little bit easier. And the one that really comes in handy quite frequently is this one here, number 5. And number 5 kind of makes some sense logically. What number 5 is saying is that if I'm taking the integral from a to b of f of x dx, and I'm adding it to the integral from b to c of f of x dx, that it's really the same thing as taking the integral from a to c of f of x dx. And if I'm drawing like a very simple all positive polynomial, it's very easy to see. Here is point A, here is B, here is C, that's a C. So the integral from A to B would be the area under the curve there. The integral from B to C would be the area under the curve there. So clearly adding those two together would give me the integral from A to C. From an algebraic standpoint, what it means is that if the upper boundary of integration on one, and I'm adding it to another one where that same upper boundary is now the lower boundary, I'm going to say this and I really shouldn't, but these two kind of cancel out, and that's how I'm going from A to C. So in this particular problem here, I can see that as far as this is concerned, the definite integral from 2 to 1, so I've reversed the upper and lower bounds of f of x dx, that is equal to +4, because it's the opposite of the integral, the negative of the integral, so it's +4 instead of -4. And if I add that to the integral from 1 to 5 of f of x dx, well, I can see that that is equal to 6. 4 plus 6 equals 10. So using algebra and the calculus rules, that's how we can get the answer to those. Let's try a couple more. So I have the integral from 1 to 5 of f of x minus g of x dx. So I have a function and I'm subtracting another function from it. Well, I go back to my rules and I see that this rule right here tells me that if I'm adding two functions, finding the integral of two functions that are added together, and they have the same upper and lower boundary, I can just divide them into two separate integrals and do the sum or difference right there. So this one here is the same thing as saying the integral from 1 to 5 of f of x dx minus the integral from 1 to 5 of g of x dx. And I can see that, well, this part here is equal to 6, and this part here is equal to 8. So 6 minus 8 would be negative 2. The only thing different about part F is that instead of just f of x, I have 4f of x. Well, I can still do the same thing. This is one function minus another function. This would have a 4f of x dx. And what I would do is I would pull that 4 through the integral. So it would look like this. So then this becomes 4 times 6 minus 8. And that should give me an answer. What's that? 24 minus 8. What is that? 16? Is that right? Yeah, that's right. So those are how you might use the different rules of integration, just to kind of give yourself some practice getting used to it.